A hybrid automation framework combines the best features of various automation frameworks, such as modular, data-driven, keyword-driven, and behavior-driven frameworks, into a single, cohesive testing approach. This flexibility allows for a highly adaptable and scalable automation strategy, making it one of the most popular choices for QA teams. Key concepts of a hybrid automation framework. Combination of techniques. The hybrid framework integrates different approaches: modular, data-driven, keyword-driven, and sometimes behavior-driven testing, leveraging the strengths of each to create a more powerful framework. Flexibility and adaptability. This framework allows testers to choose the most appropriate technique for each test scenario. For example, you can use keyword-driven tests for easy-to-understand, non-technical steps, and data-driven tests for scenarios requiring multiple data sets. Separation of concerns. The hybrid framework maintains a clear separation between test scripts, test data, and keywords, enhancing maintainability and making it easier to manage changes in the application or test scenarios. Reusability of components. Reusable components from modular frameworks, such as functions or modules, can be combined with other techniques like keywords or external data sources, enhancing code reuse and reducing redundancy. Enhanced collaboration. Non-technical stakeholders can contribute to test cases using keyword-driven aspects, while technical testers focus on scripting and module development. Components of a hybrid automation framework. Test scripts. Core scripts that drive the test execution, often leveraging reusable modules or keywords. Modules/functions, reusable pieces of code for specific actions, such as navigating to a page, filling out a form, or verifying outputs. These modules are often reused across various test cases. Keyword files. Keywords represent high-level actions that map to underlying code or modules. Non-technical team members can use these keywords to build test scenarios without detailed knowledge of the code. Test data. External data sources, like Excel, CSV, JSON, or databases, drive the inputs and expected outcomes for the test cases. This makes it easy to run the same test scenarios with different data sets without modifying the scripts. Object repositories. Centralized storage for UI elements and locators, ensuring changes in the application UI affect only the object repository, not the test scripts. Configuration files, settings that define test environment parameters, such as base URLs, browser settings, and credentials, making the framework adaptable to different environments. Logging and reporting. Components for tracking the execution results, errors, and generating comprehensive reports for analysis. Exception handling. Robust error handling mechanisms to manage unexpected scenarios, making the framework resilient to failures. Benefits of a hybrid automation framework. Maximized reusability. Combining different techniques allows for maximum reuse of test scripts, data, and components, reducing overall test development time. Improved maintainability. Clear separation of data, logic, and keywords makes maintenance easier, as changes often impact only one part of the framework. Scalability. The framework can be easily extended by adding new keywords, modules, or data sets without significant restructuring. Reduced redundancy. Reusable components and modular test scripts minimize duplication of code and effort, leading to a more efficient testing process. Ease of use for non-technical users. The keyword-driven approach allows non-technical users to create or modify test cases without needing in-depth programming knowledge, enhancing collaboration across the team. Data-driven testing supports running the same test cases with multiple sets of data, increasing test coverage and reliability. Enhanced test coverage. By combining various testing techniques, the framework supports a wide range of testing scenarios, from UI to API to database validation. Challenges of a hybrid automation framework. Complexity. Combining multiple techniques can lead to a complex framework architecture that requires careful management and documentation. Initial setup and configuration. Setting up a hybrid framework involves significant initial effort to configure the different components and ensure smooth integration. Skill requirements. Teams need to have diverse skill sets, including coding, keyword creation, data management, and tool configuration. Dependency management. As the framework grows, managing dependencies between various components, modules, data, keywords, becomes crucial to prevent conflicts. Example workflow of a hybrid automation framework. Design and identify reusable components. Analyze the application under test to identify potential reusable actions or modules, example login, navigation. Develop modules and keywords. Create reusable modules for common actions and define keywords that represent high-level actions for non-technical testers. Integrate test data. Use data-driven techniques to externalize inputs and expected results, enabling tests to run with various data sets. Create test cases. Assemble test cases by combining modules, keywords, and data inputs, providing a flexible approach to testing various scenarios. Execute tests. Run the test cases, utilizing the framework's built-in error handling, logging, and reporting capabilities to capture and analyze results. Maintain and update. Regularly update the framework components as the application evolves, ensuring test cases remain relevant and accurate. Popular tools supporting hybrid automation frameworks. Selenium WebDriver, often combined with TestNG, JUnit, or other testing frameworks for modular and keyword-driven testing. Appium, for mobile test automation, integrating easily with hybrid frameworks. Cucumber, for integrating behavior-driven development, BDD, with keyword-driven and data-driven testing. Robot Framework, a versatile tool that naturally supports a hybrid approach with built-in keyword-driven capabilities. Postman and Rest Assured, for API testing, which can be integrated within the framework to provide end-to-end testing capabilities. A hybrid automation framework offers the flexibility to adapt to diverse testing needs, making it a powerful choice for teams working on complex and rapidly evolving software projects.